Hello everyone, welcome to OneClass. My name is Shanjida and today I'll be going over some commonly asked chemistry questions both at the high school / university and college levels. And I'm currently a second year human biology student studying at U of T. And lastly, if anyone needs additional schoolwork help or needs tutoring, you guys could check the description box below. And other than that, we'll get started. And so the first question for today says, what is the molar mass of calcium hydroxide? Okay, so molar mass of calcium hydroxide, right? So we're trying to find the molar mass or the molecular weight for calcium hydroxide. And so one of the crucial steps to find the molar mass is to know the chemical formula of that compound. And so, okay, so in this case, we're trying to find calcium hydroxide, right? So calcium hydroxide. And so the chemical formula for this is CaOH. So you have one atom of calcium, one atom of oxygen, and one atom of hydrogen. You're trying to find the molar mass of this compound. And so the first step would be to basically break down the whole compound into their individual atoms. And so if I write the molar mass of calcium hydroxide is equal to the molar mass of calcium, right? We have calcium plus the molar mass of oxygen plus the molar mass of hydrogen, right? So you can see that we have three individual elements here that make up calcium hydroxide. So the next step would be to basically find the molar mass of these elements. So in this case, let's find the molar mass of calcium. And so this is given in your periodic table. And so if you look at our periodic table here, we can look at calcium, which is group 2, and it's the third element going down. You can see that calcium has a molar mass of 40.08 grams per mole. Okay, so this is your units for molar mass. And so the next step would be to find the molar mass of oxygen. And oxygen is in group 6. So you can see that it has a molar mass of 16.00 grams per mole. And lastly, we have to find the molar mass of hydrogen. And hydrogen is given right here, group 1, and it has a molar mass of 1.01 grams per mole. Right? So in this case, you can see that each of the atoms only have, so each of the elements are represented by one atom. There's no additional, there's no like, so each of them are one. We don't have like double or triple of any of them. So in this case, if there was, for example, 2 calciums, you would have to multiply the molar mass by 2, and it goes for the same as for the rest. So the next step, what we want to do is add all the three numbers together, and you would get sorry, I forgot that OH has A2. So in this case, you would multiply this by 2, also multiply this by calcium hydroxide. The formula is CaOH O2. Okay, mistake. Okay, so you would have to multiply the oxygen and the hydrogen by 2. And in this case, what you have is 40.08 grams per mole plus, so 2 times 16 is 32.0 grams per mole plus, so 2 times 1.01 is 2.02 grams per mole. Okay, so the last step would be to add all the three numbers together, and you would have 74.1 grams per mole. Okay. And so the molar mass of calcium hydroxide is 74.1 grams per mole. Okay. So this is what they've got. So the solution is correct. So the next question says, what is the molar mass of aluminum? So, molar mass of aluminum, right? So as you guys know, the aluminum is an element of in the periodic table. So this is literally given in your periodic table, and you can see from here, aluminum is group 3, and it has a molar mass of 26.982 grams per mole. So it's 26.982 grams per mole. And so since this is not a compound, right? Aluminum is not a compound or a molecule. It is an atom slash an element. So another way to find your molar mass is equivalent to your atomic mass unit of an element. And if you guys recall that the atomic mass unit is, you find the atomic mass unit by adding the number of protons plus the number of your neutrons. And we know that the number of protons is equal to the number of electrons of any given element. And it's stated like on the top left or right corner of the element in the periodic table. In this case, aluminum has 13 electrons and 13 protons. We can say this is 13. And the number of neutrons, in most cases, if you have a normal isotope of an element, or common isotope, they all have the same number of neutrons in most cases and the same number of protons. So you can say the number of neutrons is also 13, around 13, and you would have 26, roughly about 26 AMU, which is also the same thing as your molar mass. Okay, so this is one way to calculate molar mass of an element. Basically, you won't really use this in cases of compounds, since compounds are made out of different elements, and you just have to add up all the molar masses of those individual atoms. Okay, so the solution here is so. The next question says, what is the name of the carboxylic ion that forms when each of the acids below ionizes in water? Use an IUPAC carboxylic name if the acid name is IUPAC. Use a common name if the acid is common. Okay, so what we have 4 acids here. So let's start off with the first one, which is A. Which is A, and it says acidic acid, right? Acidic acid. So what we're trying to do is find what compound will form when acidic acid reacts with water. Okay, so that's what ionizes in water means. And so what we can say, acidic acid looks like this. Okay, and we're saying that this reacts in water. Acidic acid. And so once it ionizes in water, it will produce hydronium ions, H3 is 0 plus, and it would create a carboxylic ion, which is your acetate. So you have O negative. So this is your acetate. So this is basically what you get when acidic acid reacts with water, and it gives rise to hydronium ions and your acetate ions. So in this case, you can see the acidic acid loses a proton, whereas so in this case, your water acts like a base. Okay, so it gains that proton from the acidic acid. And so the next acid which we have is benzoic acid. Benzoic. Benzoic acid, right? So we can draw this. So you know that benzoic acid is a benzene, and it looks like this. And O and H. This is your benzoic. And so this would react with water, or that's what it means by ionizing in water, H2O. And this will give rise, or this will form your hydronium ion plus your benzoate ion, right? So your OH from your carboxylic acid group, it loses a proton. So this is your benzoate. So the next one, what we have is we have propanoic acid. So we have propanoic acid. Okay. And draw this. So your propanoic acid is a 3-carbon chain because it has prop, and it looks like this. Acid plus H2O, and this will give rise to your hydronium ions plus your propanoid ion, which is the same thing that it loses. So your OH, your terminal OH group loses an hydrogen, and it becomes a negative. So this is your propanoid. Oops. And OH ion. Okay. So the next one, what we have, the last one, which is glutaric acid. So glutaric acid. So glutaric acid looks like this. Looks like it looks like so it has two carboxylic acids. Okay, and so this is your glutaric. Okay, and this reacts with water, H2O, and it will form as usual your hydronium ion. Oh, sorry. In this case, it will react with two water because we have two carboxylic acids here, so we would react it with two molecules of water, and it would produce two molecules of hydronium ions, and it would produce your glutaric ion, which looks like O negative, O negative, right? This is your glutarate, uh, glutarate ion. And so you can see that this is what these are the three acids that we have formed, or these are the three carboxylate ions that forms when each of the acids below ionizes in water. And so we can see that this is right acetate ion, benzoate ion, propanate ion, and glutaric ion. Okay? And so this is okay. So our next question says, what is the molar mass of heptane? So if you guys recall that heptane is a hydrocarbon molecule, and it also it's made out of carbons and hydrogen, right? So we're trying to find the molar mass of heptane. And as I mentioned before, to find a molar mass of any compound, it's crucial to know the chemical formula. So the chemical formula for heptane, since we know it's an hydrocarbon, we know that it consists of carbons and hydrogens. And so there's a formula for that to find heptane. So to find basically carbon, how many atoms of carbon there are and hydrogens. So if you guys recall that there's a formula that C is equal to N, H is equal to 2N plus. This is without double bonds or triple bonds. So this is when your hydrocarbon molecule doesn't have double bonds or triple bonds. This is when you use this formula. And since we're talking about heptane, so hep represents 7 from your from I think it was Roman numbers, Greek numbers, and so what you have, so you basically have heptane, right? So this means you have 7 carbons. So we can say 7, C is equal to 7, and so this is equal to 7 times 2 plus 2, which is equal to 16, right? So you can say heptane, the formula for heptane is C7H16. So what we're trying to do is find the molar mass of heptane, which is C7H16. What we do is break this molecule into their individual atoms, and what we do is say it's the molar mass of carbon. In this case, we have 7, plus the molar mass of hydrogen. In this case, we have 16. And so to find the molar mass of carbon, this is given in your periodic table. If we go back here, carbon is in group 4, has a molar mass of 12.01. In this case, we have 7, so we would have to times and multiply that molar mass with 7, so you have 12.01 plus the molar mass of hydrogen, which in this case would be multiplied by 16, and we know that hydrogen has a molar mass of 1.01. Okay, times 1.1 mole. And if you do the math here, what you would get, so once you do the math here, you would get a molar mass of 100.205 grams per mole. Okay, so the molar mass of heptane, which is C7H16, is equal to 100.205 grams per mole. This is what they've got. Solution is correct. So our next question says, draw the organic products of the following reaction. So the reaction follows a mechanism below producing an alkyl chloride. So we know that our acid in this case is HCl. So let me draw out this compound. So H. So this reacts with HCl, and this, so the mechanism over here is that this is a mechanism below that produces an alkyl chloride, and the reactant undergoes an electrophilic addition with HCl. Okay, so the way we would want to show this is what I would do, write HCl like this. So your HCl, your chlorine gets off, and your double bond here reacts with hydrogen. So this is called your electrophilic addition. And so what happens next is, so you open the double bond. This, and so this is a plus, right? Since you just broke off, or you basically lost the double bond, and so you have in this case 3 hydrogens over here. And so remember how the chlorine got off, so you have a chlorine ion right here, negative, and so this will hit attack right here. And so lastly, your product over here would be So this is your product, which is, as you can see, it would be 2 fluoro. So let's say this is your second carbon right here. The whole is also, I'll just write this, 2, 3, 4. So this is your methyl, right, attached to your second carbon also. So you have 2 chloro, 2 methyl butane, 2 methyl butane. Okay. And so this is what, so since we said it will give rise to a an alkyl chloride, and we know it did, and so this is your product. Okay. So this question is, the next question here says, what is the molar mass of ammonia? So ammonia, we're given the chemical formula for ammonia, which is NH3. And so to find the molar mass, we have to break them down into their individual atoms. In this case, we have 2, which is nitrogen and hydrogen, plus the molar mass of 3 hydrogen. So to find the molar mass of nitrogen, this is given in your periodic table. And nitrogen is right here, group 5, and it has a molar mass of 14.01 grams per mole, plus the molar mass of hydrogen, which is 1.01. In this case, we have 3, so we multiply this by 3, 1.01 grams per mole. So what we would do next is we can multiply, we have 14.01 grams per mole, and multiply this, we will get 3.03 grams per mole, right? And add all this together, you have a total of 17.04 grams per mole. So the molar mass of ammonia is around 17.04 grams per mole. Okay. So yeah, this is that. Okay, so our next question says, what is the temperature of the following values on Fahrenheit and Kelvin scales? So A, sublimation of ice, of dry ice, which is negative 78.5 degrees Celsius. Okay, so let's do A first. So A. Okay, so sublimation of dry ice at negative 78.5 degrees Celsius. Negative 78.5 degrees Celsius, right? Okay, so Celsius to Fahrenheit, right? So we need to basically convert Celsius into Fahrenheit, since it wants the following values on the Fahrenheit and Kelvin scales. So we would have to convert Celsius to Fahrenheit and Celsius to Kelvin. So there's a conversion factor. So I'll say formulas. Okay, so you have Celsius to Fahrenheit. Your formula is basically degrees Celsius times 9/5 plus 32. This gives you your degrees in Fahrenheit. And so degrees Celsius to Kelvin. This is where you have the degrees of Celsius plus 273.15 gives you your Kelvin. Okay, so using these in mind, we can now do A. A says that we have a Celsius we have negative 78.5 degrees Celsius, and we have to convert this into Fahrenheit. And so let's convert this into Fahrenheit first. Write this. Okay, so we're converting Celsius to Fahrenheit. And so you have negative 78.5 degrees Celsius. Multiply this by 9/5 plus 32. And this would give you negative, we did the math here, would give you, so you would basically multiply this out, so you have 109 degrees Fahrenheit. Okay, so you can say that negative 78.5 degrees Celsius is equal to negative, or is the equivalent of saying negative 109 degrees Fahrenheit. So let's do where we convert Celsius to kelvins, and you have negative 78.5 degrees Celsius plus 273.15. When you add this together, you have 194.65 Kelvin. Okay, so 8.5. The same thing as saying 194.65 kelvins. Okay, so now for B, let's say for B, we have body temperature of human body temperature, which is 37 degrees Celsius, and we will want to convert this. So let's do Celsius to Fahrenheit, and you have, so Celsius would be 37.0 degrees Celsius times 9/5 plus 32, right? And so this would equal to 98.6 degrees Fahrenheit. And so the next one, where we convert Celsius into kelvins, the conversion factor was 37 degrees Celsius plus 273.15, and this gives you 310.2 kelvin. Okay, so these are our answers. And so we got negative 109, 194, 98.6, and 312, 310. So the solution is correct. Our next question says, how do you find density in the ideal gas law? So For ideal gas law, the ideal gas law has a formula where it is your PV, which is pressure times volume, is equal to the number of moles times the ideal gas constant times your temperature, right? Where P is pressure, this is volume, number of N is the number of moles, R is the ideal gas constant, and T is your temperature. And so what we're trying to find is density, and if you guys recall, density is, we're trying to find density. So if you guys recall, that density has a formula which is m over v, right? Mass over volume. So we're trying to find density in terms of our ideal gas law. And so this is our main goal, right? So since we have PV is equal to nRT, just write this here. So since we have PV is equal to nRT, you guys recall that our moles can be represented by mass over molar mass, right? Since our molar mass is equal to mass over moles, so our moles would be basically, our moles over here over molar mass. So we can rewrite this as, we can basically replace n by m over m molar mass RT. Okay, so in this case, what we can basically say for density is, so density can also be written like this. So density, so the symbolic version for this is like it looks like a small case P. I forgot what this is called. Okay. So this is, as I said, is defined as a mass per unit volume, right? And so what we can say, we can isolate, so we can basically rearrange the equation to isolate density. And in this case, so we would use PV, basically use PV. So we're using PV is equals to m over molar mass. So this is your moles times RT. What we can do is rearrange the equation so that it will give us density. So what we need to do is just move the mass to the other side. Okay, so so what we want to do is move the molar mass over here. Okay. Oops. So what we want to do is first get rid of the molar mass from the denominator, and what we need to do is multiply with both sides. Okay. We got rid of this, so you have molar mass times pressure times volume is equal to mass times RT. And so what you want to do next is you would want to get rid of, so you would want to basically what you want to do is get rid of the RT to the other side. So you would have, so you would want to divide both sides by T. Right, so this is equal to mass. And so we're almost there. We just now need volume, and to move volume to the other side, we would divide this by V also. Here, V's get cancelled, and so you have M over V is equal to your molar mass times pressure over your ideal gas constant and temperature. Okay, and so you know that M over V is density, and so we can say that your density is equal to molar mass times your pressure over ideal gas constant times your temperature. Okay, so this is how you get the answer, and this is correct. So our next question says, enter the KSP expression for the solid AB2 in terms of the molar solubility S. Okay, so basically the KSP is a solubility product, which represents the product of the molar concentration of the constituent ions, each raised to the power of stoichiometric coefficients in the equilibrium equation. So in this case, what we mean, so let's say we have an equation where AB2, which is a solid, is A ions plus aqueous plus 2B aqueous, right? So it dissolves or breaks down into the individual ions. So let's say this is equation 1. Okay, and so using the definition above, the KSP for this equation is equal to your products raised to the power of their coefficients. Okay, so in this case, you can say A has a coefficient of 1, so it would be raised to the power of 1. So you have A to the 1 times 2 times B raised to the power of 2, right? So since B has a coefficient of 2, it would be raised to the power of 2. So this is your equation 2. So now what we do, we substitute the molar solubility to get that, and to get them, we make the ice table for this equilibrium reaction. So let S be the molar solubility of basically the product. In this case, it's a salt. And so let's make an ice table. So you have your initial concentration, your change in concentration, and your equilibrium, right? Equation. So in this case, we have our reactant and our product, and okay. And so we know the initial concentration of our products is 0. It would be 0, 0. So the change in concentration, this would be negative S, since we are basically we're basically getting rid of, since all of our reactants is going to the products, we say that this is, you're basically decomposing, in other words, breaking down the compound into your into ions into the product. So this would be negative and this would be positive because you're forming them. And so you can, so this would be 2s, right? Since it has a coefficient of 2, so 2s. And so your change in constant, your equilibrium equation or equilibrium would be S. And in this case, this would be this would be 2s. Okay, so now we then plug this in the equilibrium expressions into equation 2, right? Equation 2, if you guys remember, it's our KSP equation. So we would substitute S and 2S into the equation. So you have your KSP is equal to concentration of A times the concentration of squared. So you have, this would be S, and this would be 2S to the power of 2. So you have S times 4S squared. And so if you multiply this, you will have 4S to the power. So your KSP is 4S to the power of 3. And so this, you can say, this is your KSP expression. Okay? Our KSP equation. Okay? And this is cut. Okay, so our next, the next question says, to find basically what the gram formula is. Gram formula mass is basically they're saying to find the molar mass of ammonium chloride. And so let's write this down. So, oops, ammonium molar mass of ammonium chloride. What we would do is break this down into their individual atoms. And so we have nitrogen, hydrogen, chlorine. So you have your molar mass of nitrogen plus the molar mass of your hydrogen. In this case, you have 4, and the molar mass of chlorine. Okay. So what we do to find the molar mass of nitrogen, we can see from our periodic table, it is 14.01. So we have 14. Add that with, we would multiply your molar mass of hydrogen with 4 atoms with 4 by the molar mass of hydrogen, which is 1.01, plus the molar mass of chlorine, which is given over here, and it's 35.45. Okay. And so we have 14.01 plus 4.04 grams per mole plus 35.45 grams per mole. Okay, and so the last step would be to add these 3 together, and what you would have is 53.5 grams per mole. And so your molar mass of ammonium chloride is molar mass of ammonium chloride is 53.5 grams per mole. And we can say that this is number 3. Okay, so this is okay. So our next question says, what are the most common weak bases? And so your common weak bases to first address weak well, bases, we should first state how they come from, or where does the notion come from. And so basically a Bronsted-Lowry acid, so we call bases and acids from Bronsted-Lowry theory. And so our Bronsted, so it's our Bronsted-Lowry acids are basically any species that's capable of donating protons or your H plus ions. On the other hand, a Bronsted-Lowry base is a species that's capable of accepting that proton. So you can basically say acids lose proton and your base accepts. So according to the theory, it's that it can only function as an acid in the presence of a base or vice versa. And when the Bronsted-Lowry acid donates a proton, it forms a new species termed a conjugate base. So when your acid loses the um, acids loses the proton, and the other species, the once it react product, accepts the hydrogen or the proton, this becomes, in other words, your conjugate base. This is known as conjugate base. And so, in the same manner, when a Bronsted-Lowry base accepts a proton, a new species termed is a conjugate acid. Okay, so when um so accepts, so we can say, or like this, so accepts, and so when this goes to a product, okay, this would be a conjugate base, and this would be a conjugate. And so basically what we're trying to find for this question, it says a weak, what are the most common weak bases? And a weak base is a kind of base that basically does not fully dissociate in aqueous solution. And so let me write that down. A weak base does not dissociate in aqueous solution completely. So that's why it's weak. It doesn't have the ability to dissociate completely into their ions in an aqueous solution. And so a Bronsted-Lowry base is defined as a proton, as we mentioned, acceptor. However, for a weak base, it is also called a chemical base with incomplete protonation. So it can't really it can't accept protons, and once dissociated in water, a weak base gives off only small quantities of hydroxide ions. So it doesn't produce its ions when it reacts with water, and while leaving a large portion of undissociated molecule of the base. So you're basically saying you don't get much of your products. And so a list of common weak bases are, for example, weak bases. So there's a list where you have ammonia, ammonia. Okay, so this is NH3. Oops. NH3. And you have, for example, ammonium hydroxide. So this is NH4OH. Okay. In some cases, water is also considered a weak base. And basically, your conjugate bases of weak acids. So this is one important one. So conjugate bases of weak acid. Okay. And so these are some common, and there are many more, but these are basically the common ones. And so yeah, they have listed more here, but the idea is the same. So the solution is correct. Okay, so our next question says, what is the molar mass of calcium chloride? Okay, so calcium. Okay, so the chemical formula for calcium chloride is CaCl2. Okay, and to find the molar mass of calcium chloride, we should break this down into the individual atoms. And to do that, we have the molar mass of calcium plus the molar mass of our 2Cl or two chlorine atoms, right? So the molar mass of one calcium atom over here, let's say calcium is group 2, and it has a molar mass of 40.08 grams per mole. Okay, and in this case, we have 2 chlorine, so we would multiply the molar mass of chlorine by 2. Chlorine is right here, and it's 35.45. And what you have, so you have 40.08 grams per mole plus, so 2 times 35.45 is 70.90 grams per mole. And when you add these two together, you would have 110.98 grams per. Okay, so your molar mass of calcium chloride is 110.98 grams per mole. So, okay. So the solution here is correct. And so basically, that was the end of our session. If you guys like this Q&A, please subscribe to the OneClass channel, like, share, comment on this video, and if anyone needs additional like one-on-one tutoring services or has their own personal questions they want to ask, you guys could check out the description box below, follow the links and ask your questions. Other than that, I'm Shanjida, and I hope to see you guys soon. Bye-bye.